Hello class, great to see you again. In this video, I'm going to discuss with you the answers for Chapter 6 Polynomial, Program Smart Mathletics. Question 1. We're going to solve the questions on a polynomial which can be divided by x and x minus 4, but leave a remainder of 42 when divided by x plus 3. First of all, A, we need to determine the value of A, B, C. B, we have to factorize polynomial px completely. And finally, we are going to find the remainders of px when it's divided by 2x minus 1. A, we are going to determine the value of A, B, C. So from the information given, px is divisible by x. So that means that we can substitute the value of x as 0. So there is no remainders. So we will get the value of C equal to 0. Second information is that px is also divisible by x minus 4. That means that we can substitute the value of x as 4 to get the remainder 0. So we substitute the 4 into the polynomial. We can form the first equation for a plus b equal to negative 16. And another information that we can get is that the polynomial leave a remainder of 42 when divided by x plus 3. So for these cases, the value of x that we can use is minus 3. So we substitute the x equal to minus 3 into the polynomial to get the remainder of 42, and we can form another equation, that is equations 2, 9a minus 3b equal to 69. Okay, we solve the equation 1 and equations 2, so we can easily to find the value of a as 1 and b as negative 20. B, we are going to factorize the px completely. Since the polynomial is divisible by x and x minus 4, so that means that this both is the factors. So we expand the factors, the divisor as the x squared minus 4x, and we use the long division to find the third factors here. And we must make sure that there is no remainder. The remainder should be 0. And after that, we rewrite the polynomial in the form of this, that is the polynomial equal to the divisor multiplied with the quotient plus the remainder. So this is the quotient and this is the divisor. So you will have the complete form of px is the x, x minus 4 and x plus 5. So factorize completely. In the part C, we are going to find the remainders. We must apply the remainder theorem. That is the remainders as the p of 1 over 2. Okay, so we evaluate until we get the remainder as the negative 77 over 8. Questions 2, we are going to solve for a polynomial which can be expressed as the x plus a qx. So that means that this will be the divisor and there is the no remainders. Okay, so we are going to show that the a equal to 2 and the value of qx is as this. And then we determine the set of value of a such that all the zeros of px are real numbers. So are real. So part A, we are going to show the value of a as 2 and the polynomial qx as shown above. Okay, so since it's given, the px is equivalent to the expression of x plus a multiplied with qx. So since there is no remainders, so no remainder, that means that the x plus a should be a factor because there is no remainder. Remainder is 0. So that means that the x plus a should be a factor. So we may use the remainders theorem. Okay, we just substitute the value of minus 2 into the polynomial and we solve it. You will notice that. So there is no remainders when we substitute the x equal to minus 2. So therefore, since the x equal to minus 2, so we can bring forward as the x plus 2 equal to 0. So this should be a factor. So that means that x plus 2 is a factor. So we can say that the value of a should be equivalent to 2. Since it's given, the polynomial px is equivalent to x plus a multiplied with the qx. So that means that x plus a here, x plus 2 is a linear factors. So the qx should be a quadratic. So we may use the comparison methods to find the qx. So we start to expand and we collect the like term and we make the comparison. So we compare the coefficients of x cubed and coefficients of x squared and the constants. Okay, we make the comparison as this way. So 2b minus 3 equivalent to a. And then the coefficient of x squared, 5b equal to the b plus 2a. And we will get the value of b in the b plus 6. And finally, we compare the constant to C equivalent to 10, so we may get the C as 5. And we rewrite the Qx as the 2b minus 3x squared plus the b plus 6x plus the 5. So we show the expressions. B, we are going to determine the set of value of B such that all the rows of Px are real numbers. So we have to recall back, so in order for a quadratic expression become real numbers, so we have to make sure that their discriminants so is greater or equal than 0. So from the informations given, so we already have the Px as the term of x plus 2, 2b minus 3x squared plus b plus 6x plus 5, whereby this is our quadratic for Qx. Okay, so x plus 2, so we get the minus 2 as the 0 is already a real zeros. So how are you going to prove that? So the quadratic is also a real root. Let me show you. So if all the zeros of Px are real, so the 0 of the Qx must be also real. Okay, so since we know that this is a quadratic, so we may assume that this is the A and this is the B and this is the C. So we may make sure that the discriminant should be greater or equal than 0. Okay, we do until we get a quadratic inequality. So we solve by using the sign table. We should choose the region which are positive. So this is the two region. Therefore, in order to make the quadratic is positive or is also real, so we have to choose the set of value of b as the b should be less or equal than 4 or b should be greater or equal than 24. Question 3, we have two parts of questions for the part A. So we are going to given a polynomial px where m and n are real constants. So when polynomial px is divided by x minus 1, the remainder is 2. If 2 is one of the roots of px, determines the value of n and n. Hence, we need to factorize the polynomial px completely. For the part B, based on the informations on part A, so the sum of roots of a quadratic is the sum of all the roots of px, and the product of the roots is the product of all the roots of px equal to 0. Okay, we are going to determine the quadratic equations in the form of ay squared plus by plus c, and hence find the roots of these quadratic equations. So for the part A, we're going to find the values of m and n based on the information given. So when polynomial px is divided by x minus 1, the remainder is 2. So we may say that the p of 1 equal to 2. And if 2 is one of the roots of px equal to 0, so that means that so p of 2 is equivalent to 0. So based on the polynomial given, so we substitute the value of x equal to 1 for the first information here. So to form a first equation, m plus n equal to 1. And based on the second information, p of 2 equal to 0. So we can form our second equation, that is the 4m plus n equivalent to minus 20. So we solve the equation 1 and equations 2. So we may easily get the value of n as 8 and the value of m as negative 7. So we can form our polynomial px as the 3x cubed minus 7x squared minus 2x plus 8. So for the questions part B, so we can use the concept of a quadratic equation with the root of alpha and beta. We may easily form by using the formula x squared minus the alpha plus beta x, which is the sum of root, plus the alpha beta, which is the product of root, equal to 0 as a quadratic equation. So based on the information from the part A, the polynomial px will have the root of 2, and the root of x equal to 4 over 3, and the root of x equal to minus 1. Okay, so we find the sum of roots, so you will get the value of 7 over 3, and the product of roots, so you will have the value of minus 8 over 3. Based on this information, so we may use the formula of y squared minus the sum of root plus the product of root, so you will get a quadratic equation. So since this quadratic cannot be factorized, in order to find the root, we may use the quadratic formulas, okay, to get the value of y as the 3.174 and the negative 0.8403. For question number 4, so we are given x plus 3 and x minus 1 are two of the factors of polynomial px. We are going to determine the value of r and s and then find the other factors of polynomial px. Hence, we are going to express the expressions x squared minus 2x plus 21 over px in partial fractions form. So we are given that x plus 3 is a factor, so we may use the value of minus 3, p of x minus 3 equal to 0. So the factors theorem to form the first equations. And then we use another information, x minus 1 is a factor, so we use the value of x equal to 1. That is the p of 1 equal to 0 by using the remainders theorem or factors theorem again. So we are going to form our second equations. We solve the equations 1 and equations 2. So we will get the value of r as 6 and the value of s as 5. So now we can get the polynomial in the term of x cubed minus plus 6x squared plus 5x minus 12. After that, we may use the long divisions to find the other factors. So first of all, we convert or express the divisor with the factor of x plus 3 and x minus 1. So to get the quadratic form x squared plus 2x minus 3, and we use the long divisions to get our quotient. So whereby this quotient is the other factors. So we may rewrite the polynomial in the factorized form x plus 3 multiplied with x minus 1, x plus 4. So whereby the third factor is x plus 4. Finally, we are going to convert the expressions of x squared minus 2x plus 21 over px. So the px is a 3 linear factors here. So in the partial fractions form, so we have the a over x plus 3 plus b over x minus 1 plus c over x plus 4. And then we equalize the denominators and make the comparing the numerators to find the value of a, b, and c. So for these cases, we are easily, if we use the method of substitutions value, so for these cases, we may substitute the value of 1, minus 4, minus 3, and so on. Okay, so we need 3 only substitute value. So we start with the x equal to minus 1. So we get the value of b equal to 1 and the x equal to minus 3. You will get the value of a equal to minus 9. And finally, when we use the value of x equal to 4, we may get the value of c equal to 9. So after that, do remember to rewrite the fraction into the partial fractions form. So for question number 5, based on the characteristics provided above, we need to find the polynomial of py and express the py over y minus 1 square in the partial fractions form. Based on the information given, so this is the polynomial of degree 3. So we may rewrite the general form of the polynomial as the ay cubed plus the by squared plus cy plus d. Okay, from the information file, the coefficients of the highest degree is 1. So this means that the coefficient of a, the value of a should be 1. So we will have a polynomial in the term of y cubed plus the by squared plus cy plus d. So now we only need to find what is the value of b and c and the d. Okay, so from the information for the second derivative of the polynomial, when substitute the x equal to 0 is 4. So from the information from the polynomial, we do the first derivative and second derivative. We substitute the value of 0 and we were going to get the value of b as 2. And from the information tree, so it says that when the polynomial divided by y minus 1, the remainder is minus 8. So the p of 1 is equivalent to minus 8. So we may use this information to form the first equations. And from the information too, it says that the polynomial py have the factors of y plus 1. So that means that the p of minus 1 will be 0. So we can form the second equations. So we simply solve the equation 1 and equations 2. So we'll get the value of c as minus 5 and the value of d as minus 6. Okay, now we may have the polynomial as y as the y cubed plus the 2y squared minus 5y minus 6. For the questions B, we need to convert the py over y minus 1 square into a partial form. And we notice that this is an improper fraction, so that we need to use the long divisions and rearrange the polynomial in the form of y plus 4 plus the 2y minus 10 over y minus 1 square. Okay, y plus 4 is where you get the information of your quotients, and the 2y minus 10 is the remainders. Okay, so we only consider this as the partial fraction, or you only convert this part into a partial fraction. Okay, we proceed. So we notice that this is a repeated linear. So we have the 2y minus 10 over y minus 1 square as a over y minus 1 plus the b over y minus 1 square. And we equalize the denominator and we make the comparing. So we may easily find the value of b as minus 8 and the value of a as 2 by using the substitute value methods. And after that, we rewrite the partial. So rule remembers to write your quotients. Okay, after that, only proceed by your partial fraction. So here is what you get from this.